Hello students, today we will do basic number system. Very important part in many competitive exams. Let's have overview of this session. First of all, we will discuss different type of numbers. Then we will do example based on different kind of numbers. Then we will learn various divisibility rules and we will do applications of these rules. Then we will learn three summation formulas and will practice sums based on these formulas. This is the very first type of numbers. This is called natural numbers. They are also known as cardinal numbers, counting numbers. Now, what are these natural numbers? These are 1, 2, 3, 4, and so on up to. So we can say all the positive complete numbers, they are known as natural numbers. That is a very basic number. Now the next thing, come to whole numbers. Whole numbers are 0, 1, 2, 3, 4 and so on up to. I mean, if we assign 0 to the list of natural numbers, we'll be getting whole numbers. So these are all the positive complete numbers including 0. These are known as whole numbers. Now come to integers. Integers is superset of whole numbers. These are all the whole numbers 0, 1, 2, 3, 4, so on up to, and their negatives also. I mean -1, -2, -3, -4 and so on up to. So it means all the positive complete numbers, all the negative complete numbers and 0. They will complete the list of integers. Decimals are not allowed here, fractions are not allowed here. Now we can talk about two type of integers. One is called negative integers and another thing is called positive integers. What do you mean by negative integers? The numbers -1, -2, -3, they are called negative integers. We are using a negation sign here. Positive integers, the numbers +1, +2, +3 and so on up to, they are called positive integers. There is one more thing, one point to remember. 0 is neither a positive number, positive integer, nor a negative integer. We can say that 0 is a non-negative integer, or we can say that 0 is a non-positive integer. Now the next thing is rational numbers. What do you mean by rational number? As you can see this word here, ratio. So any number which can be put in P by Q form, or very precisely I can say those numbers which can be expressed in ratio of two integers, they are known to be rational numbers. So by definition I can say any number which can be put in P by Q form where P and Q, they both are integers, where denominator, which is Q here, that is non-zero. These type of numbers are called rational numbers. There can be one more definition. See, that was fractional form. Now, if we talk about decimal form, any number which is terminating decimal or non-terminating but repeating. These two types come under rational numbers. Now we can take examples. If we talk about terminating decimals, for example, if I take 3.7, or we can take 0.7523. These are terminating decimals. These are ending decimals. These are known as rational numbers. Now come to the second type of rational numbers, that is non-terminating but repeating. I mean, if we take 3.777 so on up to, which is written as 3.7 bar. So 7 is coming infinitely many times. Or we can take one more example. If I take 0.7523, I'm taking bar over 23. It means this number is nothing but 0.75, 23, 23, 23. This 2, 3 is repeating. This block, which comes under bar, this block is repeating infinitely many times. These two type of numbers, they are known as rational numbers, because these numbers can be put in P by Q form. We have discussed it earlier. Now come to the next type, irrational numbers. What do you mean by irrational numbers? That is exactly the reverse of rational numbers. Those numbers which cannot be put in P by Q form, which cannot be expressed as ratio of two integers, these are known as irrational numbers. We can take various examples. Very popular examples are pi exponential e of root of anything which is not a perfect square. These three are very popular irrational numbers. Once again, what do you mean by irrational numbers? Those numbers which cannot be put in P by Q form, which cannot be expressed as ratio of two integers. They are known to be irrational numbers. So you should remember these irrational numbers. The very first is pi. Usually we take 22 by 7 value of pi. But this is not the exact value of pi. That is the closest rational number to pi. So 22 by 7, this is rational. But pi, that is irrational. Now come to exponential. That is again irrational number. Now come to the third type. You take perfect square of anything. For example, I'm writing two things, root of 4, root of 6. Now what is root of 4? That is plus minus 2. Of course, plus minus 2 can be written as plus minus 2 upon 1. So this is a rational number. But if we take root of 6 and if we calculate its value, it will be non-terminating plus non-repeating decimal. It will not terminate as well as it will not repeat. That's why this is irrational numbers. Now come to the third type, even numbers. The numbers which are divisible by 2 are called even numbers. For example, -4, 0, 2, 4, 6, 8 and so on. We can say table of 2. That is a collection of even numbers. Or if we go by definition, you take any number and if we divide it by 2, we are getting some quotient here. If the remainder is 0, then this number is called even number. I mean, if 2 divides any number completely, that particular number is known as even numbers. We can talk about positive even numbers, negative even numbers, as well as we can say 0. That is also an even number. Point to remember, 0 is also an even number. Now come to the second type, odd numbers. What do you mean by odd numbers? Reverse of even numbers. Once again, if I take any number and if we divide it by 2, we'll get some quotient. If remainder comes out to be 1, then the star number will be called odd number. Or if 2 is not dividing a number completely, that particular number will be called odd number. As you can see the examples, 7, -15, 5, 9, 1, 101, 1001, 1003, they all are list of odd numbers. Now, these are some operations on odd and even numbers. Now, if we take, I'm taking the very first example. If we take odd plus odd, we'll get an even number. We can go by example. If I take any two odd numbers, for example, I'm taking 3 and 5. If we add up these two numbers, I'll get 8, which is an even numbers. So I can say odd plus odd, that is always even. So by taking various examples, we can write that even plus even is always even. Odd plus even is always odd. Even plus odd is always odd. I'm using E for even, O for odd. Now odd minus odd. Here comes the subtraction part. I can take one more example. If I take 7, which is an odd number, and 3, I'm taking the subtraction part, I am getting 4, which is an even number. So I can say odd minus odd, this is always even. Even minus even, this is also even. Odd minus even, that is odd. Even minus odd, that is odd again. Now come to multiplication part, odd into odd. Once again I'm taking example. If I take 3 into 5, it will give you 15. Now 3 is an odd number, 5 is an odd number, and 15, the resultant, is also an odd number. So I can say that odd into odd is always odd. Even into even, that is again even. Odd into even, that is again even. We can take example. If I take 7 into 2, it comes out to be 14, which is an even number. Once again, even into odd, that is also an even number. We can take more examples. For example, I'm taking the exponent thing. I mean, if I take odd raised to power even, and the second thing is odd raised to power odd, third is even raised to power even, and the fourth is even raised to power odd. Now, once again, you can take various examples. If I take odd raised to power even, obviously I'll get an odd number. Odd raised to power odd will give you odd number. Even raised to power even, it will give you even number. And even raised to power odd, it will give you once again even number. That's it for even and odd number. Prime numbers. What do you mean by prime numbers? Those positive numbers which have exactly two positive factors, or we can say those positive numbers which are divisible by either one or itself. They are known to be prime numbers. For example, if I take 2, if I write factors of 2, these are either 1 or 2 itself. If I take other number 3 and the factors are 1 and 3. If I take 7, the factors are 1 and 7. If I take 97, factors are 1 and 97. See, we are talking about positive factors here, since prime numbers concept is valid only in positive numbers. So these numbers are known as prime numbers. Now these are the points to remember. 2 is the only even prime. What do you mean by even numbers? We have done it. Those numbers which are exactly divisible by 2, they are known to be even numbers. So 2 is the only even prime. If we drop 2, the rest of the primes are odd. Now the second point, there are 25 prime numbers. You should remember this figure. 25 prime numbers up to 100. If we talk about 1 to 100, there are 25 prime numbers, and these are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89 and 97. In total, there are 25 prime numbers up to 100. Now the next thing, how can we check whether a number is a prime number or not? To check whether a number is prime, for example 113, we don't need to check all the factors below 113. The square of 10 is 100 and that of 11 is 121. Therefore, test if any of the prime numbers less than 11 is a factor of 113. What do you mean by that? See, I'm taking the same number 113 and taking its closest square root. See, we know what is 10 square? 100. What is 11 square? This is 121. 113 lies between 100 and 121. So, its square root will be 10 point something, we can say that, because 130 is lying between 100 and 121. That's why its square root will be 10 point something. So we will check all the primes less than equal to 10 point something, and we'll check the divisibility for 130 by these primes. For example, less than equal to 10 point something primes are 2, 3, 5 and 7. So we will check 113 whether this number is divisible by these 4 prime numbers or not. If this number 113 is divisible by any of these prime, definitely number will not be a prime number. But if 113 is not divisible by 2, 3, 5 and 7, then definitely we can say that 113 is a prime number. For example, as you can see, if we divide 113 by 2, what will be the remainder? 1. Remainder should be 0. But here remainder is 1. That's why 113 is not divisible by 2. So by using various divisibility rules, we can see that 113 is not divisible by 2, 3, 5 and 7. So 113 is a prime number. You can perform the conventional division as well. Now come to composite number. Exactly the reverse of prime numbers. A positive number, see this word, a positive number which has factors other than itself and 1 is called a composite number. For example, if we talk about 9, for 9 factors are 1, 9 and 3 as well. For 16, we can write many factors. 1 and 16, obviously they are factors. We can write 2, we can write 8, we can write 4 as well. For 25, 1 and 25. But there is one more number which is dividing 25, that is 5. That's why 25 is not a prime number, rather a composite number. Once again, there is one more important point to remember. 1 is neither a composite number nor a prime number. See, prime numbers has exactly 2 factors. Composite numbers has more than 2 factors. I mean at least 3 factors. 1 falls in neither of the category, since 1 is divisible by 1 itself. 1 is the only factor of 1. That's why 1 has only 1 factor. That's why 1 falls in neither of the category. So 1 is neither a composite number nor a prime number. Now come to the next thing. This is greatest natural number of n digits. See, you can see this word, greatest natural number of n digits. A number consisting of n nines is called the greatest natural number of n digits. We can take a smaller example. If I want to write greatest natural number of 2 digits, suppose, if I take n as 2, that will be 999. If I want to write greatest natural number of 3 digits, it will be 999. I mean, you write 9 every time. N number of times you write 9, that will be the greatest natural number of n digits. Now come to the next variety, that is smallest natural number of n digits. You should remember these definitions. A number starting with 1 and followed by n minus 1 zeros is called smallest natural numbers of n digits. For example, if we talk about 3-digit smallest number, we'll start it with 1 and we will write 2 zeros. As you can see, the number of digits are 3 and this is the smallest natural number of 3 digits. Now let us come to the questions. Find the greatest 5-digit number which is a multiple of 13. See, we want to find the greatest 5-digit number. There is one added information. It should be a multiple of 13. So, how we can proceed? We will perform the conventional division. What is the greatest 5-digit number? That is 9 written 5 times. And we want a number which is a multiple of 13. So, we'll divide it by 13. Normal division. So you can see that 3 is the remainder when 5 times 9 is divided by 13. We are getting quotient as 7692, and what is the remainder we are getting? That is 3. So of course we can say that this number is not divisible by 13, but we want a number which is divisible by 13. So how can we do that? If we subtract this remainder, which is 3 here, from 5 times 9, we will get what? We will get 99,996. Now definitely this number, the new number, will be divisible by 13, and that is the greatest number. So this is the answer in this case. Now come to the next question. Almost the same thing. Find the smallest 5-digit number which is a multiple of 12. Once again, we will apply the same approach. What is the smallest 5-digit number? That is 1 followed by 4 zeros. Since we want a multiple of 12, so we'll divide it by 12. Now once again, we are performing the conventional division. So we are getting 4 as the remainder. Now if we subtract 4 from 10,000, I get 9,996. This is not a 5-digit number, but in question we need a 5-digit number. So we can do one more thing. What is the difference here? That is 8. Either you can subtract 4 from 10,000 or you can add this difference to 10,000. If we add 8 to 10,000, we will get 10,008, which is exactly divisible by 12. So this is the answer in this case. We can do one more thing. See, if we subtract 4 from 10,000, we'll get a 4-digit number which is a multiple of 12. But we need a 5-digit number. You could add 12 to this number as well. You'll get the same answer once again. So you will get the same answer, that is 10,008. You can go by either approach. Now come to divisibility rules. Very, very important concept in number system. First of all, we'll learn how can we check divisibility by 2. Very easy this is. If I take any number, say 2, 3, 4, 6, 7. Randomly you can write any number. We'll take the unit place. If this unit place is divisible by 2, then the number is divisible by 2, the complete number. If this number is not divisible by 2, then safely we can say that our number is not divisible by 2. I mean, if we take the same number 2, 3, 4, 6, 7. Since my number is ending in 7, and 7 is not divisible by 2. So this is not divisible by 2. If I take any other number, for example, if I take 2, 3, 4, 6. Here the unit place is 6, which is divisible by 2. That's why this complete number is divisible by 2. So we can say that if any number which is ending in either 0, 2, 4, 6, 8, then my number will be divisible by 2. Now come to the next divisibility rule, which is 4. I'm writing randomly some numbers. See, what is the divisibility rule of 4? If the number forming by last two places, I mean the unit place and the tens place, if the number forming by last two places is divisible by 4, then we can say our number is divisible by 4. For example, if I take this 46 in first case, since 46 is not divisible by 4, my number will not be divisible by 4. Now I can take the second example, which is 42 here. As you can see, 42 is not divisible by 4. Once again, my number will not be divisible by 4. Now come to the next example, 40. You will select the last two places, tens place and the unit place, the number forming by these two places. Since 40 is divisible by 4, as you can see, 4 into 10 is equal to 40. So this number is divisible by 4. Now come to next number, which is 16, which is ending in 16. Since 16 is divisible by 4, that's why my number will be divisible by 4. Now come to the next divisibility rules. By 8. Once again, if I write 2008, say if I write 32, if I write 2032, if I write 2800, we want to check the divisibility of all these numbers by 8. First of all, what is the divisibility rule of 8? The same thing, the extensive result. The number forming by last three places, I mean the hundred place, tens place and the unit place. If the number forming by these three places is divisible by 8, then the number will be divisible by 8. Now we can take one more time the last three places. See, these are the last three places, 008. Since this is divisible by 8, that's why we can say this number is divisible by 8. Now come to the next thing. That is easy one, 32 exactly divisible by 8. 8 into 4 is 32. Now come to the next number. Since the number is ending in 032 and 32 we know that is divisible by 8. That's why once again this number is divisible by 8. Now come to the next thing. I'm taking 800 exactly divisible by 8. Once again, this number is exactly divisible by 8. We can write one more example which is not divisible by 8. That is 2801. Now, if I take last three places 801, since 801 is not divisible by 8, that's why this number is not divisible by 8. We come to the next divisibility rule. Now you can understand, if any number, say I'm writing A, B, C, D, E, F. If any number forming by last four places of a number, if this number is divisible by 16, then we can say my complete number will be divisible by 16. That is the extension of all previous rules. So we can say that if we want to check divisibility by 2, we will check last place. If we want to check divisibility by 4, since 4 can be written as 2 square, we will check last two places. If we want to check divisibility by 8, since 8 can be written as 2 cube, so we will check last three places. If we want to check it for 16, since 16 can be written as 2 raised to power 4, we'll check it for last four places. Now you can set the correspondence here. This one correspond to this one, 2 to this 2, 3 to this 3, 4 to this 4. So I can generalize that whenever you want to check the divisibility for 2 raised to power n, you will check last n places. I think that is clear. Now we will check the divisibility by 3. Let us check for 531 and 5312. For both numbers, we will check SOD. What do you mean by SOD? SOD is sum of digits. Now in case of 531, this is 5 plus 3 plus 1, which is 9. Since 9 is divisible by 3, so we can say this 531 is exactly divisible by 3. Now I'll move to next example, which is 5312. Once again I'll check SOD for that, which is 5 plus 3 plus 1 plus 2, which is 11. Once again I'll take SOD of 11, which is 2 in this case. Now as you can see, this 2 is not divisible by 3. That's why my number 5312, that is not divisible by 3. Now same is the rule for by 9 with a little change. I'm taking the same example 531 and 5312. Again I'll check the SOD. Now you know the meaning of SOD, that is sum of digits once again. Now what is the sum of digit for 531? This is 9. Now we'll check the divisibility by 9. In previous case we were checking the divisibility for 3. Now we'll check it by 9. Since this 9 is exactly divisible by 9, that's why this 531 is exactly divisible by 9. Now come to the next case, which is 5312. Now what is the SOD here? That is 2. We have calculated it earlier. Now this 2 is not divisible by 9. That's why my number is not divisible by 9. In smaller classes, I think you are aware of that. if you want to write the table of 9, what was the trick? You write counting up to 9, then you write it once again but in reverse. That completes the 9's table up to 10 multiples. What is the idea here? Idea is to make SOD of 9 everywhere. As you can see, 1 plus 8 is 9, 2 plus 7 is 9, 3 plus 6, that is also 9, and so on. So that was not a trick actually, that was the basic rule of divisibility. Now come to the next divisibility rules, that is by 5 and by 25. First of all, by 5. If we take any number which is ending in either 0 or 5, that number is exactly divisible by 5. Or we can say, if the unit place is divisible by 5, then our number is divisible by 5. For example, if I write 235, since this is ending in 5, that's why this number is divisible by 5. I can write more example. If any number which is ending in 7, of course you can see this is not divisible by 5, as 7 is in the unit place and 7 is not divisible by 5. If we take 230, again this is ending in 0, so the unit place is divisible by 5. That's why this number itself is divisible by 5. Once again, I'm coming to by 25. I'll check the divisibility for last two places. I mean, if the number forming by last two places is divisible by 25, then my number will be divisible by 25. So we can conclude that if any number which is ending in 00, 25, 50 and 75, then those numbers are divisible by 25. Now that is the same thing as we have done in case of divisibility by 2. So if we want to check the divisibility by 5, we will check the last one place. If we want to check it for 25, since 25 can be written as 5 square, we'll check it for last two places. If we want to check it for 125, which is 5 cube, we will check it for last three places. If we want to check it for 625, which is 5 raised to power 4, we will check it for last four places and so on. The same thing we did in divisibility by 2, 4, 8, 16, 32 and so on. Now come to the last divisibility rule, that is by 11. I'm taking any number, for example 1331. Obviously you must know that 1331 is nothing but 11 cube. So directly we can say that this number is divisible by 11. But how can we apply divisibility rules? See, what is the thing? You start from unit place and take alternate place. So we are getting 1 plus 3. We'll take the addition. Now we will take the left of the places. I mean 1 plus 3. We'll take the subtraction here. I am getting 0 here. Since 0 is divisible by 11, that's why this number is divisible by 11. Once again, I'm taking another example. If I take randomly 15,425, we'll apply the divisibility rule by 11. We'll start from unit place. We'll take the alternate places. I'm getting 1 plus 4 plus 5 minus. Now the remaining thing, addition of that is 5 plus 2. Now what is this? This is 10 minus 7, 3, not divisible by 11. That's why this number is not divisible by 11. Or I can do this way as well. Let me summarize. If I'm writing any number, suppose of this length, I'm taking any 6-digit number. I want to check whether this number is divisible by 11 or not. I'll start from the unit place. I'll take the addition of alternate places. I mean B plus D plus F minus the remaining thing, A plus C plus E. If this result is divisible by 11, then my number is divisible by 11. If this result is not divisible by 11, my number will not be divisible by 11. Now come to the next thing. Actually, these are not the divisibility rules, independent divisibility rules. With the help of previous divisibility rules, we can check divisibility by 6, 12 and 15. For example, for 6, we'll check the divisibility by 2 as well as by 3. I mean, if any number is divisible by 2 as well as 3, then definitely this number will be divisible by 6 as well. For example, if I take 252, since 252 is ending in 2, definitely this is divisible by 2. Since the SOD, which is sum of digit, it is 9, and this 9 is divisible by 3, that's why this number is also divisible by 3. So I can say that 252 is exactly divisible by 6 as well. Now come to divisibility by 12. For 12, we'll check the divisibility by 3 as well as by 4. What was the divisibility rule of 3? That was SOD, sum of digit. And what is the divisibility rule of 4? That is last two places. The number forming by last two places, that should be divisible by 4. Now come to the next thing. That is divisibility by 15. Now you can make it, I think. We'll check it for 3 and we'll check it for 5 as well. For 3, what was the divisibility rule? That was SOD, sum of digit once again. And for 5, my number will be ending in either 0 or 5. So my number will be divisible by 15 as well. Now we will practice some questions based on these divisibility rules. Which letter should replace the dollar sign in this number so that it becomes a multiple of 9? See, what is the divisibility rule of 9? That is SOD should be divisible by 9. SOD means sum of digits. So we will find sum of digits in the original given number and this is 33 plus dollar. Now I want to take that value of this dollar sign so that this total becomes divisible by 9. If I take 1 here, I'll get 34. Obviously you can think that 34 is not divisible by 9. If I take 2, obviously 35, that is also not divisible by 9. So we can say that if we take 3 instead of this dollar, I'll get 36 as the total, which is divisible by 9. So what is the answer to this question? It will be 3. If we replace this dollar sign by a 3, we'll get a number which will exactly be divisible by 9. Now the next question. The 6-digit number, this is divisible by 6. How many values of A are possible? So if we take this number, this is 72A, 99A, and we want to check the divisibility for 6. We have done it. How to check it? We'll check it by 2 and by 3. What is the divisibility rule of 2? That is the last place. As you can see in the number is ending in 8. That's why whatever be the value of A, my number will be divisible by 2 always. Now what is the divisibility rule of 3? That is SOD, I mean sum of digit. So we'll check sum of digit for this number. That will be 7 plus 2 plus A plus 9 plus 9 plus 8 once again, which is 33 plus A. So we want to take that value of A for which the total sum will be divisible by 3. Now many values are possible. For example, if we put 0 here, we'll get 33 as the total, which is exactly divisible by 3. If we put 3 here, the total will be 36. Once again, the number will be divisible by 3. If we put 6 or 9, we'll get a number which is exactly divisible by 3. We cannot go beyond 9. Why so? Because A is a digit. Digit takes value from 0 to 9. So 9 is the maximum value we can take. So these 4 values are possible. So many answers are possible for this question. Now, another formulas, very important. These are known as summation formulas or sigma formulas. The very first formula, sigma n. What is sigma n? Summation n. That is 1 plus 2 plus 3 plus so on up to n. I mean, sigma n is nothing but sum of first n natural numbers. That is 1 plus 2 plus 3 so on up to n. And what is the answer for this? This is n into n plus 1 divided by 2. Now come to the next thing. Sigma n square. Now you know the meaning of summation or sigma. It will be 1 square, 2 square, so on up to n square. I mean, sigma n square is nothing but sum of first n perfect squares. What is the answer for this? This is n into n plus 1 into 2n plus 1 divided by 6. There is one more important formula, sigma n cube, summation n cube. That is nothing but sum of first n perfect cubes. That is 1 cube, 2 cube, n cube, and the answer for this is n into n plus 1 divided by 2 its whole square. Sometimes we write this is sigma n whole square because sigma n is nothing but n into n plus 1 divided by 2. You should remember all these formulas. Now question based on these summation formulas. Find the sum of first 10 natural numbers. Now you know the definition of natural numbers. We'll start from 1. We'll go up to 10. What is sigma n formula? That is n into n plus 1 divided by 2. So nothing but sigma 10 is asked. So we can take n as 10. We can put the value in the formula. I think you are comfortable in these minor calculations. So what is the answer in this case? It will be 55. That is the answer. Now come to these practice questions. In total there are 5 questions and these are the answers. Thank you so much students. Happy learning. Best of luck for your exams.